Yes, it should work now. Yes, it worked. And then stop this transcription. And then stop sharing. Share. And it should be on the screen. Great. So, first of all, for who missed already the seminar of last week, the aim of the seminar of last week actually is to set up the Spider and the Python on your computers. If you go to the lecture of last week, at the beginning of the lecture, there is a link of how to set up something called Anaconda. So Anaconda actually is a platform. It's education platform. And by downloading the Anaconda, you will get something like this. So I recommend, if your computer is good enough, you can download Anaconda first. Take some a minute or so. And then from Anaconda, you download whatever you want to use, like Spider that normally I am using during the lecture, or you can download Jupyter if you prefer to use Jupyter. If you would like to use R, we will not teach R, but Anaconda actually is umbrella that has a lot of things underneath it. So you can either download Jupyter, you can download Spider. If you would like to write your code with Visual Studio, no problem. If you would like to write your code with R, but R we don't use it. So you can see here, once you download the Anaconda, just if you write Anaconda in the search bar for Google, you will go to their website. You create an account, I think, first, or if you don't need to create account, is okay as well. It's a free program. You download it, and once you download it, you will have like all of these sub-programs ready. So some of this program is, for example, this program I already downloaded. You can see here. So you can just press launch and you will launch it. If you find another program that you are very interesting, but it's not in your computer, you can just press install. Okay. And I assume once you download the Anaconda, it's automatic download Python with it. So by downloading Anaconda, it's already set up the Python on your computer. And then what you need to do is to see how you would like to write the code. I am using Spider, this program, but you can use Jupyter if you like Jupyter. Okay, it doesn't matter which program you will use to write the code. Okay, so this actually was the aim of the last workshop. So since you already missed this one, you can try today downloading Anaconda, download Spider or Jupyter in your computer, download the Python. And if you have any challenge, we will try to solve this Thursday. Of course, with Elisa, we start to go a bit ahead. So actually, I think she is now a bit far away from you. She now starts to succeed to deal and handle with a different file. So please, Elisa, don't interrupt us today.
Okay.
Yeah, because now you have very advanced knowledge in this sense. So, and this is good actually, because we can use you as a reference. So if anyone has any challenge, just ask Elisa. Great. So today actually, I need to close this one. Okay. So in last lecture, we got like introduction of what type of variables. And we know that the text, if you are working with text, for example, if your master thesis or PhD thesis has something to do with text, like interview people or so, this is text. You need to save this text in something called string. And you start to deal with this. If your master thesis or PhD thesis deal with chemistry, with number, with something you can count, you need to have either integer or like this, like this, I see. Okay. This is the thing that the boxes that you put number. Great. And then during, yeah, please.
I just saw that it's like a mute symbol there, but it's
No, it's this.
okay.
Good. And then in the seminar, during the previous seminar, you succeeded to download some database. I have to say it's still simple database, but you need to think about how to make it a bit complicated. Okay, because as you will see, the database that you download for this course is very simple to compare to what we will get today. Okay, great. So now we understood that we have these boxes, and we understood you as a researcher, you will put your data into these boxes, and then we will do something out of it. So normally, the first step after adding the data into the different boxes, the first step is to clean up the data. Okay, so after adding this data in boxes, which we call it harvesting data or collecting data, and we put it in the box. And as I explained to you at the first lecture, this page will be almost our last lecture. So in our last lecture, we did a full lecture about how we can harvest data. Okay, so you can fill out these boxes either by your data that you are created through interviews, through your lab work, or your data that you collect in your thesis, or you can harvest it from the web. So we assume we will have this data, and then the next step is to clean up. Okay, so actually this lecture and the next lecture is for cleaning up, just to understand how we can clean the data. What's the different process that we will do in order to clean the data? So what's after cleaning up the data? We will use the data that's cleaned into get some statistic. And then we will use the same data that's cleaned to visualize it. And this is both you need in your data section for your master or PhD. So these two things you need to have it in your master or PhD thesis. So your thesis normally start with introduction, then methodology, and then data section. For the data section, you present your data. And in order to present your data, it's not possible to present tables. Because reader table is very heavy. You can't read the table. Okay? But you can read statistic. You can say this variable x, is range between this value to that value. The average of this variable is this amount. Or you can visualize it. Okay? After that, after you reach to this, we will go to something to simplify the data a bit. I think we will get two lectures how to simplify the data. And this is, we will introduce it a bit today, which is something called PCA, Principal Component Analysis. Okay. And after that, after simplification of the data using PCA, for example, this is one of the methods that we can use to simplify the data. Normally, you go to something called feature engineering. And feature engineering is to choose the features or the variables from your data that can be used in the machine. Okay, and then you can start running machine. So actually, all of these steps you should do before starting any machine learning process. So we are just here to clean up. Okay, great. So no need for that now. Yep. Okay, so this is a sort of explanation of what I did. So you get raw data. Raw data means that data you collected from your master work, your PhD work, from the lab, from people, from interview. You start to tabulate this data. So you structure this data, okay, in files, in different files, as you like. You can put it in 100 files, no problem. But each file has certain structure, and you know, my file here include interview data. This file includes the lab from the results from the lab. This includes observation from the field. And then you collect these files together and you start the pre-processing. Okay, which is the topic of today. And then you start to explore the data, start to understand what's inside this data. And this is the statistic and the data visualization. Okay. So this is the process. You collect the data, you make data pre-processing, data visualization, and after data visualization, you start to build your model and you evaluate your model to make sure that your model is working well. Why this is important? Why the stage of today is, I think it's one of the most important part of when you are dealing with data, because simply there is a rule say rubbish in, rubbish out. So if you have a perfect model ever, and you just feed this model with rubbish data, you will get rubbish model. You will get rubbish result. Okay, if you're writing your thesis, you have like the best way to write in academic writing, and you use rubbish data for your thesis, master or PhD, you will not get any result. Okay, so the data is the core of your thesis or any scientific research. Well, what is the data pre-processing? So data pre-processing refers to a set of techniques and steps performed on raw data to transform it into a format that is suitable for analysis and machine learning algorithms. It's an essential step in data pipeline and involves several key tasks. And actually, the majority of the course is in the data pre-processing. So today and next lecture, next week, we will focus more on data cleaning and data integration. Okay. After that, for lecture after, we will go to see data transformation and data reduction. Okay. Data reduction is the PCA, the principal component analysis. This is one of the things that we use to make data reduction. So this is just a few things. This is some common steps that you need. And maybe here I can reflect on the exam for the people who in the master, not PhD, because PhD you don't have exam. For the master exam, as I told you, it's easy peasy, not very difficult. We will sit together in the last lecture and we will make the exam together. But the exam, it's coming from this point. Okay? So data cleaning, this step involves handling missing data, remove duplicate, dealing with outlier and noisy data. And so if you have a database, exactly what you could download it, maybe there is missing data, right? I think one of the challenges that you already faced, you have several databases, and one of them is monthly, one of them is yearly, I think, and one of them is daily. So it's impossible to work with this data. It's impossible to work with this data. Like I have 3 types of data. I have daily observation, I have monthly observation, and I have weekly observation. How I can deal with that? So I need a way in order to merge everything together. So if you have duplication in the data, you don't need to have duplication in the data. So if you have the same observation that collected in the same day, you need to remove this. If you have any data that missing, we need to find a way to fill out this data. And if you have noisy data, we need to remove this noisy data. Okay, and the noise data, and I will come to the noise data in one second. Data integration. Data integration is actually this is what you will do in not maybe the coming seminar or the seminar after, because now you download a set of data that include 3 variables, like 1, 2, and 3. I think you have 3 variables in your database for the master student. And you would like to integrate it with another type of data. You need to increase, you need to add more complexity to your data set to understand what's behind the data. Okay, and this means that you will integrate 2 types of data. You did some interview in your PhD, okay, and you asked stakeholder, for example. This is 2 different types of data. This interview of citizen and this stakeholder, but you need to combine both of them. So this is data integration. So data integration, you are combining different data within a big database in order to analyze what's inside it. Data transformation. So simply data transformation is, if we say, for example, we collect 2 sets of data, and one of them is the distance between cities. And this distance between cities, between European cities, in kilometer, because Europe uses kilometer. Okay? And in your study, you compare it with US. And you get data from US, and they are used miles. So the distance there is miles. So you need to transform the units from mile to kilometer or from kilometer to miles. So you can't work with the data if you have one unit or one variable that have 2 different ones. So you need to work with this data transformation in order to scale the different numerical value, or not only the just numerical value. So for example, yes and no. If you have an survey and you ask colleagues about something and the answer yes or no. Maybe you think, okay, I would like to change because the computer will not understand yes and no. You can change it to 1 and 0. So everything yes is 1, everything no is 0. And then from that, you start to work with numerical. So this is data transformation. Feature selection. I don't think in the course we will go for the feature selection, but actually feature selection, all of the course aim to go for the feature selection. Because when you are starting to make your machine learning code, you need to select the feature that you will train the algorithm with. So if you have data that include 10 10 variable, maybe only 3 of them you need. The rest you don't need. So you need to select only 3 variables, 4 variables. And this is what we call feature selection. And in order to do this feature selection, in order to select which variable, you need to go a bit in detail. So actually here the course is not only to present data, is not only to clean up the data. You need to go a bit deeper to understand what's underneath the data. Because if you didn't understand what is underneath the data, what is the variable that important, very important in the data, you can't go to the next step. You can't go to the machine learning. You need first to understand your data, get all of these variables to understand what's the relation between them, and then go to the next step. Of course, understanding the relation a bit difficult. Maybe it's easy to have like as the data that you download, 3 variables, easy peasy, you can understand them. But if you have 100 variables, how you can understand this? So you need to have a lot of visualization. You need to have a lot of statistic work in order to understand the relation. And most probably you will go to the PCA, the principal component analysis, in order to reduce the dimension of your data. This is the PCA, the dimension reduction. And this is, it's like mathematic calculation. We will not do the mathematical calculation, but we will use it. So we will explain it. You will understand how it works. And or you will have the code behind it to do it. Okay? And simply, the PCA, the principal component analysis, this is if you have like a database that include 100 variables, you can reduce this 100 variable into only 3 variables or 4 variables. So this new variable understand or take into the consideration all of the 100. Okay, and we know how we can calculate this. Okay, Kata, or no? Okay. So if you have a data that include 100 variables, for example, and we need to start to make this machine learning things out of it, it will be difficult to assess this 100. You need years to understand what's the relation between this. Okay, if we go a bit to make it in practical way, if we go to the sustainability science, if you see that the planetary boundary, we have 9 planetary boundary, and this 9 planetary boundary are interconnected, and within each one we have several variables. So if you say there is 100 or 200 variables that control this 9 planetary boundary, and we need to understand what's the relation between them, we need to understand this relation, right? How we do that? It's a bit complicated. We need to reduce this number. How we reduce it? It's mathematical calculation. So we will do it. We have like 1 or 2 lectures just to understand how we do it. But the PCA is to reduce this number from 100 to 2, 3, 4, depending on the system. Okay? But don't worry, we will get a full lecture for this. Yes.
Now I know what.
Yep. So data discretization, this is simply to group the data. So if you say, for example, we have the data like length, for example, and we say the length is 1 kilometer, 2 kilometers, 3 kilometers, 20 kilometers. 30 kilometers, 100 kilometers, for example. So you have groups of data that give lengths. So this one actually to group them into subgroups. So from 1 to 10, for example, this is group 1. From 20 to 40, this is group 2. Anyone between 100 and 500, this is group 3. Okay, so this is just to group the data. Handling imbalanced data. This is actually, if we say, for example, if we say this student, group of students, we would like to understand the distribution of the age in this group. Okay, and we say, okay, Kata is 20 years, Elisa is 21, Vicky is, say, for example, 21, again, 22. Okay, so everyone is 20, 22, 23, 24 in this range. And then a person who has come, one student, he is 45, 60, something very old, very old guy. Okay, and we start to do this analysis, statistic analysis. Do you think this will be fair? Not be fair. Every one of you will be a bit higher, and you will see that the average age of our group will be 30, 35, right? Because this guy is 60, 65. And this is not fair for you, right? Right. And this is handling imbalance. So we need to remove this guy and say, okay, this guy actually make noisy in our database. Good. And this is, if you say, for example, we make like an analysis of or develop an AI model to calculate something like something related to logistic. And in this logistic machine learning tool, we need to feed to the program the distance between the cities and all the distance between 200 to 400. And then there is one city that has a distance of 1,000 kilometers. Okay, so if we added this city into our algorithm, it will cause damage for our algorithm. So we need to remove this or find a way. How to find this? Okay, it's not here. Yeah, actually it's here. How to find this? Something called oversampling or undersampling. Okay, oversampling is to scale it down or scaling up. Like this guy who is coming, we can say, okay, we will scale your age down. So if everyone here was average 22, you will scale down to be 22. Or we agree that everyone will scale up to 60. Okay, so we can scale it up or scale it down or just remove this guy. Yep, data splitting. I think this is one of the most important things, and you need to at least understand this. Once you clean up the data, you work with the data, clean up. This can be like for weeks, for months. Before you start to feed the data into your machine learning, you need to split the data into two categories, something called training data and testing data. Okay, and this should be before starting the developing of the machine learning tool itself. Okay, there is some people, they do it wrong. They take all the data, you work with the data, you clean it, you visualize it, blah, 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 and then you get all the data, this your final data. You get all the data, and then you feed it to the machine learning algorithm in order to train the algorithm itself. And after you have the machine learning tool, they get a piece of this data and test the algorithm. You use this data before. This is the data that you feed them, so you can't use it again to test. So it's better before you go here, you split this data into two things: training and testing. Training will go to the machine learning algorithm, and once you create this one, you test it with the test. Okay? This is what we call it data splitting. Easy peasy? Simple? Any question? Good. So now we go to the hard part. Okay, so now we will start to introduce you the first two Python package that we will use from now on until the end of the course, and hopefully you will use it further in your PhD and your master work and your coming research. This is something called Panda and NumPy. Okay, and we will use both. But I will present now what is this, what is that, and then by the end, I need to set up the alarm to have a break, right? Or you can stop me when you are tired. Okay, so we will use this. Normally, when you are downloading your Spider or Anaconda or the tool that you will use in order to write your code, your program, you will have this tool with you. Okay, but if you don't have it, you need to write this by install and then NumPy by install. Okay. One code you need to understand it, something called by list. And by install. Okay. Byte list will list all the Python package that you have in your computer. Great. If you start to work with a package, for example, package that made for machine learning, as we will take in 2-3 lectures from now, and you didn't have it because normally it's not installed with your package, you need to first pipe list. Pipe list, it will show you everything. You can go through this list to understand if this package is there or not. If it's not, you can use pipe install and then the name of the package. Okay, and this is, yep. Sorry. Ah, yeah, of course. But why it doesn't work? Invalid. Okay. Why invalid? Should work. No. Ah, yeah. I think you need to type it here in the console. So I will. You see here my screen. Is it too small? Or is it okay? Yeah. Wiki. Okay. So by list. Yeah. And this is good sign. It takes some time. Okay. So now we have a list of all the packages that we have in my computer. Okay. And this is also important in something when you start get error, and I promise you will get a lot of error. Okay, you need to check this, because sometimes the error is that you are using a code that is not compatible with your version of the package, or you use two different packages that is not compatible with each other. So from time to time, you need to check what you have and check the compatibility. And of course, here it's not written the compatibility. So you don't know, for example, this X array and this YABF, is it compatible or not? But you know the version, and you can check if your code includes this two package. You can say, okay, do you think this package with this version is compatible with that or not? And then you can do your research. And if there is something is not compatible, you need just to update it. How to update it? By install. So you just install a new version or old version. Okay. Okay. So Panda, this is just like the part for the exam. Some blah 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 for the exam. Panda is a powerful Python library for data manipulation and analysis. It provides two main data structure, series and data frame. Okay. So Panda has a series. Series is, as we will see in 1 minute, it's a series, like some boxes beside each other. Data frame is simply like an Excel sheet, a table. Okay, this is data frame. Data frame is particularly popular for handling structured data in tabular form. It's similar to spreadsheet or SQL table. Panda is perfect, actually, it's perfect package for cleaning, transforming, manipulating data, making it essential tool for data preprocessing. So actually, everything we will do during this course, we will do it with Panda because it has everything. This is a key feature of Panda. It's actually used data frame. So it's two-dimension table like data structure, like column and rows. It's also has a series structure. I don't think we will use a series structure a lot, but it's one dimension label array, like one line. It's data cleaning. Panda provide function to handle missing data, duplicate data, data filtering and selection. You can use Panda in order to allow, slice the data, index the data, filter the data. You can do whatever with your table, with your data using Panda. You can rename the things as you like. Rename the boxes that we have in our stuff. Grouping the data, merge and join. And this is your project in the coming week. You will download another database and you try to merge it with the existing database. So you can merge database, you can split database. You can make time series. I would like to study only the event in 2024. My data is from 1990. I would like just to study this year. So you can make time series. And it's good, very good work package or package, because actually Panda is very well integrated with other package like NumPy and Matplotlib. Okay. NumPy is a fundamental package for numerical computation in Python. It's n-dimension array. So actually it's a bit complicated because the data frame that we have in Panda is just X and Y. We have variable and we have indexing things. Here we have n-dimension, so you can put whatever you want there. Can be two-dimension like X and Y. It can be X and Y and time. It can be X and Y and time and color. Whatever you want, you can put it there. Okay. So actually, it's efficient to handle large multiple dimension arrays. and matrix. It provides a wide range of mathematical functions to operate on these arrays, making it essential for library for scientific this library for scientific computing and numerical analysis. So if we would like to make scientific computing and numerical analysis, we go for NumPy. If we would like to handle the data, we go for Panda. And normally, when you are doing your project, you use both of them. Yeah. This is some character. It has n-dimension array. The core data structure that support vector operation make array computation faster. You can work very fast with NumPy. It has a lot of mathematical function, so you can do whatever you want with as a mathematic on the data. Broadcasting, so actually it's automatic handling operation between array with different size. So actually, if your different array or your different data in this n-dimension array different in the size, it's automatic can handle this. They can scale the data up or descale it. It's of course include random number, so you can generate random number. This is good in some cases. It's memory efficient, especially if you are working with big data. You need something to be memory efficient. And it's easy to integrate with C and C++, which is another language for programming. And I think it has also R. I think if I remember, R has also NumPy there. I assume that. This is a big comparison. Okay. Data structure. Panda use data frame and series. NumPy use number dimension array or n-dimension array. Function. Panda is primary for data manipulation, cleaning, and analysis. NumPy is used for mathematical, numerical for large array. Data representation. Normally, data in Panda is represented as spreadsheet or table, while in NumPy is actually like multi-dimension arrays. Domain of the use. Panda is used widely in data science and data analysis, while NumPy is essential for scientific or computing, machine learning, and numerical simulation. Integration, actually, both of them are very well integrated with other packages. Yeah. Now we will go to the examples, the example part, and maybe we have like a break for 10 minutes, okay, before we go to the example part. Yep. No. Yes.
Right. Mhm. 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 And you. What other database we should add in that has some nice. Are they so perfect that's collecting it? They pick them, it's never perfect.
You need a complicated database. Something very complicated.
The ocean health index. The enemies. No, we managed to handle. Like I just managed. Yeah. And so. Whether that is always messy. So you have been working with that data set before? No, it was just a little bit. That doesn't look up a little bit. It's just like a copy pasting or like a picture and then trying to make it closer. But I managed to take out the part of that we needed for the data, our data, of the moment data. Do you remember with the file? That's like many words and our data, yeah. Remember that? I think so. There was a line header about manual how to do a thing. Yeah. And then I managed to take out what we needed from the data and then made a new file. But then always have to do that with all of the files. But that's will be okay. I think it'll be easy. It's just to change one small thing. That's, yeah. No, I think we did it best. I just made a list, an empty list, and then I added in everything after acknowledgement. Into like empty list, and then I converted that then list to a CV. So it was pretty. It was just took some time to clean. You know, with the problem and just think it's complicated. You need to understand the performance of the problem and then what kind of tools you have to solve the problem. Yeah, I honestly, whenever I get a problem when I first started, I will never solve this problem. I'm too stupid to solve it. And then you can never solve anything because then you already fail. So I have to just stop thinking that. Yeah, just do it. It will be better. Ja, det här. Ja, antingen av vad fan ChatGPT expression is in there. I didn't know if you like that. It's great. In this book, I would recommend this book. Comment. Wait, I have a picture of it. Have you seen it before?
Maybe.
I was recommended this book. It's really nice. And then I went with in the library and like I was free and that's I think they're really yeah. And like they start off from how to down like this it's just it was actually
If you send it like links to it, it can circulate.
yeah, no, very things source for and especially on the online. Yeah. And then it's I never asked that you want to be able to. They used to give me only the results and then I available on was pretty. Yes, I don't
Okay. So should we start again? So make sure it's working. So now we'll start to the practical part of the lecture. So this is just to visualize what's the difference between series and data frame. Series is just one line of data, which is the value, and it's indexed by A, B, C, D, or we can index it with the Python index 0, 1, 2, 3, 4. Okay, and then the data frame, as you see, it's just a very easy Excel sheet. Columns and some rows. Great. So now we'll start to create these things. First of all, you need, this is the code. You need to start by importing your package. So you need to start your code with import bundle. Okay. So this is the things that I would like to bring to my code and import it as BD, like you can import it with as anything you need. But when you write BD in your code, this means that we will use banda, or this part of the code will use banda. Okay, and you can see here, I will create a box. This box variable called S1. So this is our box. And in order to create this box, I will create it as a series. And I will create it as a series from banda. So I will recall banda. And I will call series from banda. And I will create, or I will fill a series of 1, 2, 3, 4 under name of S1. Or I can create another series, again, banda series, and then I will fill 1, 2, 3, 4, and I will index them as A, B, C, D. Okay, so either you can make it this, easy peasy, but in this case, the indexing will be, so 1, the index will be 0, 1, 2, and 3. You remember this indexing. Okay, you start always with 0. Or you can index them with name. The first variable, we'll call it X, call it Y. Okay, good. So now I will share with you. So you will have the code with you. The lecture, I will share it once we finish the lecture today, and then you can test it at home, but you will get a lot of error. Okay, and all the error, or the majority of the error actually, is with this quotation. Okay, you need to double check the quotation, the quotation that you are using. So I will try to enlarge this a bit. Actually, it should be from here. Is large enough? Okay. So our code starts from here. Import banda as BD. Okay. And I will just close this one. If you would like to comment your file, you need to add this 3 quotation. 3 quotation, and then you can write whatever you want, and then by the end of your comment you can add another 3 quotation. This means this is comment. Okay, if you would like to add a comment for a line, you need to add just this hashtag things. Well, so import banda, and then I will create a series called S1, and this is that include a series that include 1, 2, 3, 4. And I will create another series. I will call it S2, and this is 1, 2, 3, 4, but I will index them A, B, C, and D. Okay, and I can go now and start print S1, and I will go and print S2. Okay, I get error here for S2, S1, yes, of course, because this is S capital. You see, I got an error here. Very intelligent. I get an error here because simply this is not S small, it's S capital. Good. So I will run this code. Okay, of course, you didn't see the result because this is the result part. You see here, this is S1. It's 1, 2, 3, 4. And the index there is automatic indexing 0, 1, 2, 3. Okay. And this is the S2, 1, 2, 3, 4, and the index A, B, C, D.
something. So when you're going, now the index are changed, now that you're gonna call on them, will you call on them by saying, if I want from A to C, A, and then these two dots and then C? Is that their name now? Or
Yeah.
can I say
Yeah.
zero?
No, in this case, you already change.
Exactly.
Yeah. So if we say, for example, here, instead of writing the code, print this is actually S2, right? And I need from this S2, I couldn't see anymore here. And I need from this S2, I need from B to C, for example, or D. Okay. And then, okay, they couldn't understand this. Why? Triptych error P is not defined. Okay, error is not defined. Okay. Okay, so if we go back and then try to make it 1, 2, 3, does it work? No, it's not also defined. Why? I don't know. Yeah, there is error here. So B is not defined. Why B is not defined? But it's indexed. Okay, we will see it later. Because I think there is one slide for calling the indexed series. If it's not today, it will be next lecture, but we will have it. Great, super duper. So now we understand how we can create a Panda series, right? Now we will go to make Panda frame. Okay, it's the same. So we will create a variable, a box. We call this df. You can call it whatever you want. And then we call Panda bd. And we will call from this package the data frame. So we'll create data frame. And in this data frame, we will create a column called foo. And this will include x, y, z. And another column bar, and it includes 6, 10, and none. And a third column called base, and this is true, true, false. Okay. I need to enlarge this again. Not easy to work with this. Yep. So what we will do, I will see if you are there or not. I will comment this part. And then we'll start from here. You see, data frame, Panda, okay. And then start the first column. This is the value of the first column, the second column, and so on. And now I would like to print all of this. I need to print only, print all the data frame. So df. Okay. Should I run the code? You see the code? Everyone see the code? Okay. Should I run it? What you expect to get out of this code? Error, okay. Don't say, because you are more advanced. So I will run. Oh, okay, we get error. You don't see the error, so I will bring the error to the screen. Exactly. We get the error. The error is very simple. We don't have BD. What's a BD? Sorry? I did import it? No. Actually, I commented. So I need to import it. So let us write it again. And we need to just import Panda as BD. Now you can understand what is a BD. Okay, run it. Without error. This time is working well. Easy peasy. You see? The column. Bow, bar, bad, and then the value there. Okay? Great. So now we can go to the next part. Now we would like to work with a more complicated files. We need to read and write file. Panda can read and write file. So Panda read CSV file, read text file, read Microsoft Excel, SQL. Yes. Okay. So Panda read CSV file, text file, Microsoft Excel, SQL, read Johnson, and at the same time, it's export the data to this type format. Okay. So if you have data in Excel, no problem, you can just import it. How we can read it or how to import data? As you see here, first of all, we need to import Panda as BD, and from the BD, from the Panda, okay, from the Panda, we will get read CSV. So now we'll read the file and then the file name. Or read table if you have like a text file. Read Excel if you have Excel file. Read SQL if you have a database SQL. Read Johnson if you have Johnson file. Read data frame if you have data frame or dictionary to read from. Yeah. This is an example. Now, in this example, actually, we will read from the internet. It's not file from our screen. So we'll go here. Enlarge this. Okay. So I will import Panda. I don't need this anymore. I don't need this anymore. And maybe I can comment this. Yeah. First of all, I will create a box. Okay. Variable. And this variable called URL. And you can see underneath this variable, I added a string, and this string includes the path to our file. So this is a file that uploaded somewhere on the internet. And then I will make another box, and this another box, I will call it df-data. Okay, it's box, it's just variable. And what I will put in this box, I will call Panda. So I call Panda, and I call function read. Not anything, I need CSV, read the CSV. And then where is my file? This file. So this is our file. Okay. And I added something here, print DF data. So I need to print what is inside. I need to see what is inside this box. So now you can imagine it. We are dealing with boxes. We have a box that includes the name of the file or the path to the file. And then we create another box that will import the data in it. And then using print, we just look at what's inside. Great, run this. Yep. Error. Yeah, why error? Because simply there is something that is not closed. We need to close everything. Yes, this is the part is open. So we need to close this stupid thing. So I need to add, now it's closed. Now it should work. Yes, it's working. So now you see, this is the data in our file. Okay. Easy busy? Easy. So you need to think like this, okay? What I need to see the data in my interview, for example. Great. So I need to make print. I need to print my data. To print my data. Great. But I need first the data. From where I get the data. So I will read it from where? From this file. This file can be online, can be file in your code. Okay, so go further. So this is just like the same example again. And this is the output that we got right away. And this is the code to rewrite it at home. So you need to rewrite this import panta, blah, blah, blah. This is the online file. And then this is how to download it. Well, okay. Now, if we would like to import the data without header. So the file is coming with header, like the top, the header of each column. If we write header, none, the data will come without header. Why it's important to have, sometime you need data without header because you need to call the data by yourself. Like for example, the file include, or your survey, you made a survey and you asked it, when did you born? So the guy say, I born it on blah, 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 or my age is blah, blah, blah. And you need to change this question from these things to age. So you need to import the data without header, and then you can call them as you like. Well, this is few things that you can play with if you have data, if you already download, but please try to use complicated data. And if you maybe you can use the same data that we have now, which is this data. It's very complicated data, and you can just play with it just to test. Okay. So DF, this is because our file now, the box that we, if you look at the code, this is our code. This is our code, and you see here our code, it's df-data. So actually, maybe I can just remove this one. Okay. course, printed data not existing anymore. Yep. So our box that includes the data is called df. Okay. And then you can start to play a bit with this. So df, this box, I need to see the head of n row. So you can write, I need to see the header of 1. So it will give you only 1 row. Of 2, you can see 2 row. The numbers and the value in 2 row, or 3 or 4. So you can start to go a bit inside the data to see what is written there. If you would like to see the tail of the data, like the last 2-3 rows, A, N, so they will start to account from bottom to up. DF shape, you don't need the DF, of course, as you know. You can call it any name. Vicky, for example, your data will be Vicky. Okay, Vicky.shape, it will go and give you the structure of the data. What's in this box? It will give you the number of the rows. It will give you the number of the columns. Info, it will give you the index of the data type, memory information, some information about your box, about the data that you have. Description, it will give you some description, some numerical description, like statistic description. If you would like to have all the statistic value, you need to add df describe between quotation all. You will get everything in a table. Yep. Yes.
If you want like the DS tail, and I want the 2, 5, and 7 separately, not from 2 till 7, do I just use a comma in between?
This is a good question. We can try. I don't know. But first we need to see this one. So this is just to show you. So df print, if you are write df and print the df, it will print everything. And then if you say print only the header, it will give you the number of the header. The tail, it will give you the tail that you are defined. Okay. Here to replace the header, but now we try to see our case. Maybe print the header. Okay. So here, but yeah, df. Yes. So now it will read the same file. It will save the data in df, in a box called df, and then it will print the 2 first line, 2 rows. Okay. See it. Okay. Print. So it's the same. Save it in df. Print the header of the first 2 lines. Great. So I will run this. Before I run it, I bring this here to see if we'll have result or we have error. And then run. Yep. So this is the value for the first 2 lines. Okay. Or 3 lines.
That's both of the first 2 lines.
Yes.
There's not 2, like number 2 line.
No. Both 1 and 2. 1 and 2. No, I think in this case, I think it's 0, 1, and 2. Yes, because you see here, you have this is a car, second car, and third car. So it's three variables. So you say, what if we wrote from 2 just we test. Most probably it will give us error, but just for fun. From 2 to 5. Okay. So print us the header from 2 to 5. I don't know what the result will be, but here. So I changed this. Print from 2, just I added 2 to 5 from here to there. And then see what we'll get. I hope not error. Yes, error. Okay, this is good. Method objective is not okay. So actually, this way of calling or indexing is not acceptable in this case. Not acceptable in this case.
Because that's where reference is.
Yes, in this case, but we try make another things. See if we will solve this problem or not.
Data frame to a list, and then we can call it a.
Yeah. Okay. Okay, print head to okay. No, this method is not acceptable. I think there is an error here again, and this error invalid syntax flux. Okay, it's not acceptable to have these things here. So we need to explore a bit how to call arrange. Okay, we can explore this, or you can explore this during your seminar this Thursday. Well, we have 20 minutes and we still have some slides more. Okay, now if you would like to call columns, if we need to save or to rename our columns, what we can do, now we have a box, it's called df, right? We have a box called df, right? And we understand this box include 10 rows. But we will call these rows with different names like age, name, country, things like this. What we can do is to create a second box, and we will call this box header, for example, in our case, and we will add in this box the headers. As you see here, I create box. It's list, normal list that include the header. Okay, and then I will write this df column, our column, equal to headers, and it's automatic will assign these names into the header of our table or our data frame.
Using into the box.
No, you need to write it by yourself. This is your work. Like for example, I will call the first column names, my name. So it will be my name. Second column, call it age. So it's up to you, up to the researcher. But this is just an example. It's just an example. Okay. And then once you say, okay, I will do this, it will automatically change the headers. See, I think it's already there. So you see here. No, number 0, it will be the column. This is the index. You will go from the first column. So you will name from the first column.
If I want to call for
Yes, I think this will be numbered. We need to check this. If they will consider the header as a line or not. It can be different from a version to version. It can be different from version to version. So sometime last week, I tried to use an old code, which is normally get the like the first line, and then I find that he start to say, no, this is like a header. It's not a line in your database. But you know, if it's not working like this, just change it. Because you understand how to navigate it. Yep. So here I create a box, and for symbol, I just call it 1, 2, 3, 4, 5, 26. Okay. And I use the same structure, but I think this one will not work now. I assume it will not work because now it's, we'll see. Okay. So we will change the header of the different variable with 1, 2, 3, 4. Let's see if it work or not. There is no error so far. Yeah. Yes, make it. There is no error, so they change the name. Okay, easy peasy. But actually, yes, it changed the name. Now I will go to the next thing that you need to take care of. Change the name. So now if we go to okay, we can recall name like column, and we can say here df our data, rename column equal. Maybe it's column equal. Maybe this is why it doesn't work when we try to list the column. Maybe we need to equal and then list it. Yeah. Anyway, so here rename column B to renew B. Okay. And then we put this in place equal to. Okay. So let us take this code and run it.
In place equals true.
Yes, this is my question to you. Yes. This code is not existing here, so what we can do, we just need to remove. Where? Yes, it's here. That's correct. So we need to. Yes, here. So actually here we will get column number 3. We already renamed the column 1, 2, 3, 4. So we'll go to column number 3 and we will call it new 3. Okay. And then we will add this in place true. Right. And then if we go up, this is the database called df, right? Where is df? This is df. Okay, you see here, this is our df. From 1, 2, 3, 4, 5 until 23. Okay? Okay. So close this one, and then I will come here and I will close our code till here, and then I will add a comment here. Okay, without in place. Run. No error. Good news. Good news. Good. So we will go now to see this one. Us. We have 1, 2, 3. There is no error, and we got 1, 2, 3. Where is new 3? Let's go to the end of this data frame. Where is new 3? That's correct. Should be here. You find it? No, I couldn't find it. Okay, but they didn't give me any error. Okay, why? So maybe they save it somewhere else. But this is DF. It should be in the DF. Okay. If we remove this one, because this is a difference between this is now should give us so save. Okay, again it's 26 column. 26 column, so yes.
So if we don't add in place, then nothing happens. Well, then it wouldn't put it in where 3 is.
Exactly.
Or it will become just a separate column.
Exactly. It will be a separate column and it will not be saved in the database. It will be somewhere else. Lost somewhere else. So you need to put in place true in order to make sure that you will put it there. Make sense? Try. Most probably they will give us error and then you need to explore this error at home. But why not try? False. If, and now remember our database include 26 column. Okay, we will see what will happen in the structure. Again, 26 column. Let's open the data. This one. Nothing happened.
Is it here?
We'll see if it's at the end. So false is you insert it, but you remove it because you didn't make it in place. So in place mean put it there in the data in your box. So what happened? You have a box that include data frame, and you say, okay, I need to change the header of this one. Change, but you didn't put it there in the box. So it's in the memory of your machine, but it's not in the box.
If I would say print.
See? But here, if we say print, make it false or make it true, should be true. But if we make it true, it would be there in the database. There is no point, right? There is no point. But if we say true, and then we go print df, and we need not everything, we need it should be column selection. Let's see. See? No, an error. Why is there an error? Yeah, it should be capital N. That's correct. Again, there is a problem. If we add instead of that, this one, yes, you need to add between quotation. Okay, and then save, run, error. Data frame object has no attribute column selection. So the column selection is not accepted here. So we need to change this, find another way to define this. But why there is no column selection suggested by column selection? Column maybe? Why not? Yeah. Seem to be okay. No, not okay. Okay, not okay. Maybe without this one. And we can add just like this. Yeah. Didn't get it. So we need to find a way to how to define one column there. Okay, good. But anyway, you understand what's the meaning of in place. Okay, good. Now we'd like to save the file. We have 5 minutes and we still have 10 slides. So we need to save the file. It's very simple. Our box is called df, right? To CSV file, print CSV file, and then put a bus. Easy. And then you have a bus here.
You need a path before you put the path in there.
Yes, but sometimes you can put the bus at the end, but you need to make like restructure your code. So simply you create a box that includes a bus, and then save the file to this bus. And then all your data frame will be saved there. Why this is important? So if you say, for example, you worked for 3-4 hours to clean up the data, and you already cleaned it, you're happy with that, and you need to sleep a bit, and then make your computer sleep. Okay, it's not more make logic to make this process again. So save your data, and then when you are woke up, you start again with the saved data. Okay, so df to CSV, you save it to CSV. You can save it to Excel file. You can save it to text file. You can save to something called pickle file. Okay, so you can save it as you like. It will be here in the bus. Okay, it will be in the bus. But make sure if you will use this simple code, make sure that this file is not existing there. Because if you use this code twice, the first one it will work, the second one will give you error. Why? Because the first one, it will create your data, save it in this file. Okay. The second time, it will create the data, try to save it in the file, but the file already existing. So it will not work. So you need to modify this code in order to check if the file existing or not. If the file existing, you will write it a bit different. Instead of save the data to the file, open the file and write the data in the file. So what is happening here? They take all the data, save it in the file. Okay. If the file is existing, it's much better to say the file there, open this file, get the data in, and then close. Okay. And when you write data to the file, you have two options. Either you open the file, you delete everything in the file, and then you write the data, or you can add your data to the end of the file. Okay. This will take it, I think, not today, I think next week. How to write to the file or delete all the data and make it again. Okay, this is just a summary. This is save data to CSV field, to Excel, to HTML, to Johnson, to Beckett. This will take it later. This file is very nice. It's this file, you can really use it for big data. It can take gigabytes of data in this file, and it will be easy peasy to deal with. Okay, so if you have very large data and you try to save the data in the CSV file, you will save it, but it will take hours. So you can go just and save it here. It's CSV file, it's text file, but it's much more easy to deal with. Okay. This is again like this is how to read, how to save. Okay, read just to open the file and read. Two, just to save the data. Maybe we need an example just to see this. Okay, now we have, just close this one or delete this one because this is not working. I need to enlarge this a bit. Okay. Now we have this data. Okay. We can print it again just to be sure that print df. Okay. Just to make sure that our data is there. There is no problem with the data. Error, no error, error. No error, but easy peasy. Now we go and make our file. We can take this as an example. No, maybe I can just go. This is our lecture here. Or copy. Will end in 1 minute. So no problem. Yep. And then we can say we need to put the bus here. So we need to create a new but it will be okay bus, and we will call it bus. Okay, and this bus equal to this one. And of course, this machine didn't understand this. We need to change this from this slash to backslash. Okay. So you think Mac is much better here in this case? In that, only in that case. Easy to make just your life easy to change the bus, but actually Mac is, okay. And then here in the code, I will create a file called test.csv. Okay, and I will, sorry, a pickle, okay. It's just, yeah, just yeah. And then we can go here. F2 pickle and then add okay. See? If there is any error, I hope no. No error. Yes, it should be there. I hope so. Code. Yes. Oh, you didn't see it. Our files. It was just 4.3. So in 1 minute. Okay. We can try to open it. I don't know if the computer is intelligent enough as your Mac or not, but we can try. When it was Notepad, just once. This is the data there. It's not so intelligent. Okay. So try instead, maybe saving in Pickle it has a problem. Maybe we can call it CSV. CSV. And then here we change this to CSV. Okay. Because maybe the structure of the beacon need to be opened by another thing. Okay, easy peasy, very fast. And then we can go here, code. This is our file. This is a file that is created today, 10 of September at 4.5. It's called this. Let's open it. This is our data. And nicely, they call this column newsfeed because we changed. Good. Great. So unfortunately, we couldn't finish all the lecture today, but all of the lecture is like this, like example of how to save, how to delete, how to describe the data, and you will have several the codes, like each file we have our code, like for example here. So here the code, how to write these things. Again, when you copy the code from the presentation direct to your Python program, most probably will give you error, and this error is just this quotation. You need to fix this quotation from one quotation to two quotations. Okay? Good, so see you Thursday. Bye-bye. First.
Are you bored? What's your name? How I can. Yeah, for sure. But like when we have to do like not very much. I don't know, of course. Have you been like first of all studying the entire film? Okay. Maybe you can send it. Yeah. That's mine. And what is but basically what's been done here is just that I have downloaded and I made a file to where my spam was. And then I searched the word acknowledgement, which is this word here. And this word gave me, because I started first with search find, but then I didn't get to have it. So then I went just one line over and did acknowledgement.